Okay, so now let's talk about production capacity. Production capacity is you can calculate for a facility, a work cell, a piece of equipment, all right, and we abbreviate it PC, all right, so it's the shifts per week times the hours per shift times the hourly production rate, okay? If you need to increase the production capacity over a short period of time, you might increase the number of shifts worked, like add a Saturday if the facility's not normally running them, or you might increase the number of hours per shift, okay? So let's look at this problem. If a turret lathe section has 6 machines, okay, and they all can make the same part, all right, and this section runs 10 shifts per week and about 8 hours per shift, okay, each machine makes 17 units per hour, so how many can this section make in a week, all right? So let's just start at the beginning and look at what that is. The production capacity then is going to be, we've got 10 shifts per week. Okay. And we're going to multiply that number by 8 hours per shift. Okay, then we'll take that. All right, so that tells us we have how many hours we can work a week, okay? And then we can make 17 units per hour, okay? So when I plug all that into my calculator, I get $1,300. Oops, I didn't multiply. Maybe I did multiply that right. I get 1,360 units. Okay? Now when you look at that, think why that is. Okay, the shifts cancel, the hours cancel, and I get units, and that's really per week. Okay? Make sense? Alright. Let's take that. Trying to delete. Now I've got to go back. Sorry. Okay, so we answered that. All right, utilization. So utilization is another way to look at, oh, you know what I didn't multiply that by was the 6. Okay, so we have to take that number and multiply it by the 6. So I get 1360. I knew that number seemed small, times 6. So each machine could make 1360, and so altogether they can make 8,160. Okay? Sorry. Okay, so back to where we were. Alright, utilization. That's your actual output versus your production capacity, which means you've got to calculate your production capacity usually in these machines. Okay, so if a machine operates 80 hours per week and it makes 20 units per hour, and 1 week last month it made 1,000 parts and was idle the rest of the time. So we want to know the production capacity of the machine and the utilization. So the production capacity of that machine is going to be equal to 80 hours per week times 20 units per hour. Okay, and so that's going to be 1,600, I think, but I'll just do the math to be sure. So it can make 1,600 units per week, okay? But that week it only made 1,000. So its utilization, which we abbreviate capital U, is equal to 1,000 units per week divided by 1,600 units per week. And okay, that is 0.625 or 62.5%. Okay, so that's the utilization of that machine. It was only being used about 62% of the time, right? Okay. All right, manufacturing lead time is the total time required to make a part. And that is the setup time plus the time to make the parts plus the non-operation time. Okay, and the time to make the parts is the number of parts to make plus the cycle time for an operation. Okay, so let's look at what manufacturing lead time really looks like then. Okay, so we said that the manufacturing lead time was a combination of a few things. Alright, so this example says a part is made in batches of 100 units. The batch has to go through 5 operations to be completed. The setup time is about 3 hours per operation. The average operation time is 6 minutes. Okay, that's for each of the parts. The non-operation time due to handling, delays, inspections is about 7 hours. Okay, and so we want to know how many days will it take to complete the batch if the plant runs 1 8-hour shift per day. Okay, so if we're trying to figure out what it is, okay, the time to make it, all right, is going to be equal to, all right, we said we got to do the setup time. It's 5 hours per operation. There are 5 operations, so it's going to be 5 times 3, okay, and that's hours. All right, the operation time is 6 minutes, or that's 0.1 hours. All right, there are 5 operations. It's got to go through 5 of them. Okay, there are 100 parts, and each one of them has to be processed for 0.1 hour. Okay, now the inspection time then will be 7 hours for operations. There are 5 operations, so we'll have 5 times 7, okay, hours. So when I plug all this into my calculator, I get a grand total of 100 hours. Okay, so we've got to change that into days. All right, and we say then the manufacturing lead time will be equal to the 100 hours divided by 8 hours per day. Okay, so when I do 100 divided by 8, I get 12.5 days. So the manufacturing lead time for this piece is 12.5 days. Okay, makes sense? Alright, perfect. 12.5 days. Okay, cost of manufacturing. Manufacturing costs fall into 2 major categories. Okay, fixed costs, and they're constant at any output level. Variable costs, they vary in proportion to the production output, and you can find in your textbook good examples of what some different fixed costs and variable costs are. Think about it though. Variable costs would be the cost of raw materials. Okay, the more you make, the more you have to spend on raw materials. Okay, like the cost of the building is a fixed cost. The building costs the same no matter how much you are making or not making. Okay, so the variable costs are multiplied by Q, your output level. Okay, And you see I put some of the things in here, buildings, equipment, taxes, but the variable costs are things like labor, materials, utilities. Obviously, if you make more, you run the equipment more, and so the power to run them costs more, right? So this is a chart of production quantity versus total cost, all right? So the total cost is, there are two different curves here. This one is a manual curve, right? The fixed costs are very low for manual operations, but the variable costs are high because as you make more, it's basically the cost of people. You're having to pay more and more people, and that drives the price up, okay? However, an automated process, the total cost has a high fixed cost, but the variable costs are lower, so the slope looks more like this, okay? So it's not particularly suited for low production quantities, all right? And these are obviously when you're far over here and making a lot of the product, okay, then you would say that you'd be better off to be automated because the total cost is less now, all right? So down here in this region, you would want to be manual. Here in this region of production, you would want to be automated to keep your total cost the lowest, all right? So there are different ways to classify manufacturing costs: direct labor, materials, overhead, okay? There's always factory overhead and corporate overhead. You know, these are things like sales and marketing. They're things you can't necessarily do anything about, but you're stuck with them, okay? So you're going to have to pay them. Someone has to pay for them. Obviously, the corporation is counting on you to make the product, so you have to cover the cost and the cost of the goods you sell, all right? And then if we look at a typical manufacturing cost, if this bar represents the selling price, okay, only the manufacturing cost only accounts for about 40% of that. The raw materials only accounts for about 50% of that total manufacturing cost. So that's only about 20% of the total selling price. So if you know the parts, the cost of your raw materials, they're about 20% the cost of the selling price, okay? Now, different products use different margins, okay? So this is like engineering, research and development, administration, sales, marketing, okay? That you would consider like your corporate overhead. These pieces would be part of your factory overhead. But you can see the profit margin here is relatively small. All right, well, I hope this helps you some in understanding manufacturing problems and typical manufacturing costs, and that you feel like you understand those things a little better now. Thanks.